Okay, now let's look at an important point, how we can see the generalized number of inputs, then how many ones it will count and all. So here I have made 4 inputs A, B, C, D from 0, 0, 0 to 1, 1, 1, 1. Okay, 0, 0, 0, 0 to 1, 1, 1, 1. And I have made A XOR B, A XOR B XOR C, A XOR B XOR C XOR D. I have already made the outputs, so that we won't waste time on drawing them. You can do that by yourself. Even means whenever you will see 2 inputs together, the means first you calculate this, then XOR this guy with C, so you will get this, then XOR D with this guy, so you will get this last column. Okay, so the point I am trying to make is, first if you will look at 2 inputs A and B, this is what the output will be. You will see that the output will be 1 for even number of ones, okay, in the input. So here it is odd number of ones, so output is 0. Then again here are the odd number of ones, that's why output is 0. Okay, but here if you will see even number 1 and 2 number of ones are there, so output is 1. And here also 0 number of ones are there, so output is 1. When you will take 3 inputs A, B, C, this is what you will get at the output. When you will take 3 inputs, now it will become a odd number of ones detector. So it will only have output logic high when in the input there will be odd number of ones. So in third one you can see 0, 0, 1, so only one number of 1 is there, so odd, then again odd because this is the only one, then again odd, this is the only one, again odd, this is the only one. Okay, here there are 2 ones, hence the output is 0. Here you can see again odd number of ones, then here even number of 1 is there, then again even number, then again even number, sorry, odd number. Okay, so then if you will include 4 inputs, it will again become even number of ones detector. Okay, so in the first one it is output is 1 because there is no 1 in A, B, C, D, so it is 0 number of ones is there, that is also even. Then fourth one if you will see 0, 0, 1, 1, even number of ones are there. Sixth one if you will see even number of ones are there. Seventh number even number of ones are there, likewise you can go. So the point I am trying to make is, now it depends, XOR depends upon number of ones in the input as well as how many inputs you are applying. Okay, if you are applying 2 inputs, that is even, so it will become even number of detector, even number of 1 detector. If you will apply 3 inputs A, B, C, it will become odd number of 1 detector because it's odd, A, B, C, odd 3. If you will apply 4 number of inputs, that is even, it will again become even number of ones detector. Where even number of ones? In the inputs. If there is even number of ones, then the output will be 1. If not, then output will be 0. Okay, so that is what I want to conclude. So I will write in one line so that you will get a feel. So what I am trying to say is, for even number of inputs, okay, A, B, C, D, for even number of inputs, XOR gate is an even number of ones detector. It will become an even number of 1 detector, and for odd number of inputs, that is A, B, C or A just, then it will become, XOR will become odd number of ones detector. Okay, so in this case it will show, XOR gate will show output 1 when there will be even number of ones in inputs. Okay, and in this one the output will be high when the inputs have odd number of ones. Okay, that is what the crux is. So they don't perform exactly similar, XNOR and XOR. Okay, so it's slightly different. Okay, let's look at an example here. First example, second example. Here you can see 1 XNOR with 0, XNOR with 0, XNOR with 1, XNOR with 1, XNOR with 1, XNOR with 0. Here 1 XNOR with 0, XNOR with 0, XNOR with 1, XNOR with 1, XNOR with 1. here there are 7 inputs, here there are 6 inputs. Okay, so we have to calculate what is the output. Okay, what will be the final output of this, what will be the final output of this as well. So directly you don't have to think any means like logic, you don't have to come up with, you just see how many inputs are there. 7 inputs, 1 2 3 4 5 6 7. 7 means odd, and in odd XNOR works as odd number of inputs, XNOR 1 works as odd number of ones detector. Okay, if there will be odd number of ones means the output will be 1, else it will be 0. So whether there is odd number of ones or not, so 1 2 3 4, 4 number of ones are there means even, hence the output will be 0. Okay, so that is the output. So now let's look at the second example. Here there are 6 input, 1 2 3 4 5 6 inputs are there. 6 means even. For even, XNOR works with even number of inputs. Okay, inputs. If for even number of ones, XNOR works as even number of ones detector. Even number of ones detector. If there will be even number of ones total in the input, means the output will be 1, else the output will be 0. How many ones are there? 1 2 3 4. 4 number of ones are there means even, hence the output will be 1. So that is how you apply this property. Okay, so sometimes it is very long, 1 XOR ... like this very long sequence will be given, I mean 9 10 inputs, then this property will be very helpful. Just look at whether number of inputs are even or odd and decide based on that. Okay.